Hi, this is Mr. Ward, and this is a video key for Geometry Exit Ticket 23.1. So let's go down to the questions that you might need help with. So once again, I've reviewed these two theorems, well, this definition and this theorem 40. So I'm asking a few questions before I ask you to jump on the proof. So consider this. What is a line that is definitely parallel to TP? And how about TR? Well, since SX is perpendicular to plane M and also plane N, what that means is that any line that goes through the foot of SX, and in this place it's T, and in this case it's X, any line that lies on that plane is going to be perpendicular. And lines that are perpendicular, two lines that are perpendicular to the same line are going to be parallel. So TP is going to be perpendicular to ST, and XZ is going to be perpendicular to ST here. And what you also need to get is that SXZ make a plane. So STP and XZ are on the same plane. So we can treat, because TP and XZ are on the same plane and perp to SX, they are also parallel to each other. Same with TR and XW. So XZ is parallel to TP, XW is parallel to TR. And that's going to come in handy later on in the proof because it'll allow us to figure out some angles. All right, so what's an angle that's definitely congruent to TSP? Well, we're going to be able, so TP and so TSP. So you're going to be able to prove, since so TP and TR are congruent, all right, you are going to be able to prove that so STP and STR are congruent because ST is congruent to itself. TP is perpendicular to ST, and TR is perpendicular to ST because they go through the foot of a line of SX, which is perpendicular to plane M. And so we can start saying some things. We can say that's a right angle and that's a right angle. So those are right angles. And because of that, because this is itself, and because we can say that these two segments are congruent, then we'll be able to say side angle side for STP and STR, and that'll lead us to TSP being congruent to TSR. Okay. And that'll be by Kappa-Kadika. So angle TSP is going to be congruent to angle TSR by Kappa-Kadika after proving that triangle STP is congruent to triangle STR by side angle side. So that'll be useful for us as well. All right, now, how would we prove that triangle SXZ and triangle SXW are congruent? Okay, and what would that tell us about SZ and SW? Well, what it would tell us about SZ and SW is that they're congruent, because if these big triangles are congruent to each other, then SZ and SW are congruent by corresponding parts of congruent triangles. All right, let's take a look at some things that we can say. We can say already that this angle here and this angle here are congruent, because we could prove that STP and STR as triangles are congruent by side angle side. So Kappa-Kadika tells us those angles are congruent. Cool. We also know that this angle is a right angle and this angle is also a right angle because SX is perpendicular to N and XZ and XW both go through the foot of SX. And then we can say SX is congruent to itself. Okay, so if SX is congruent to itself, then we've got angle, side, angle. So we can use angle, side, angle to prove that triangles SXW, triangle SXW is congruent to triangle SXZ. Okay, and once we've gotten that, we can say that SZ is congruent to SW by Kappa-Kadika. And now we have that would actually tell us that SZW is isosceles. So that's actually what we needed. So we need these big triangles to be congruent to each other. Okay. So really, we may not actually need any of these angles here. We really just need this top angle, these angles to be right, and this to be congruent to itself, because everything else will fall into place. So let's start off by simply proving that STP and STR are congruent as triangles. So after the givens, we can now say that angle STP is congruent to angle STR because perpendicular means right angles, and right angles are congruent. Okay, we can also say ST is congruent to ST by reflexive, and now we can say that triangle STP is congruent to triangle STR by side, angle, side. Side, angle, side. Because we already knew that TP and TR were congruent. Once we've got that, we can say that angles STR is congruent to angle STP. Let me go and make sure you can see which ones those are. TS. I apologize. Let me correct that. TSP and TSR. Okay, so TSP and angle TSR are congruent by Kappa-Kadika. Okay, now we can say side, or we can say SX is congruent to SX by reflexive. We can say that angle SXZ is congruent to angle SXW because perpendicular means right angles and right angles are congruent. Okay, once we have that, we can say that triangle SXZ is congruent to triangle SXW by angle, side, angle, because what we now know is these top angles are congruent, this side is congruent to itself, and SXZ and SXW are congruent. So angle, side, angle gets us that. Once we've got that, now we can say that SZ and SW are congruent by Kappa-Kadika. So SZ is congruent to SW by Kappa-Kadika. And then finally, we can say that triangle SZW is isosceles by definition well, I should say because two sides are congruent. Okay, and then you're done. I hope that helped. So ultimately, by proving this triangle was congruent to this one, STP and STR are congruent, we can prove these angle TSP and TSR are congruent, which then allows us to prove that triangle SXZ and SXW are congruent. And that allows us to prove that SZ and SW are congruent, which demonstrates that SZW is isosceles because it has two congruent legs. All right, there you go.